But I decided we might as well get it over with now. Now that we introduce vectors, you can add and subtract. You might as well learn about multiplication. It's sort of the job is done. It's like going to the dentist. It's a little painful, but it's good for you. And when it's behind you, the pain disappears. So I'm going to talk about multiplication of vectors, something that will not come back until October and later in the course. There are two ways that we multiply vectors. And one is called the dot product, often also called the scalar product. A dot B, a fat dot. And that's defined as it is a scalar, A of x times B of x, just a number, plus A of y times B of y, that's another number, plus A of z times B of z, that's another number. It is a scalar. Has no longer a direction. That is the dot product. So that's method number one. That's completely legitimate, and you can always use that. There is another way to find the dot product, depending upon what you're being given, how the problem is presented to you. If someone gives you the vector A, and you have the vector B, and you happen to know this angle between them, this angle theta, which has nothing to do with that angle theta, it's the angle between the two, then the dot product is also the following, and you may make an attempt to prove that. You project the vector B on A. This is that projection. The length of this vector is B cosine theta. And then the dot product is the magnitude of A times the magnitude of B times the cosine of the angle theta. The two are completely identical. Now you may ask me, you may say, gee, how do I know what theta is? How do I know I should take theta this angle, or maybe I should take theta this angle? I mean, what angle is A making with B? It makes no difference, because the cosine of this angle here is the same as the cosine of 360 degrees minus theta. So that makes no difference. Sometimes this is faster, depending upon how the problem is presented to you. Sometimes the other is faster. You can immediately see by looking at this, it's easier to see than looking here, that the dot product can be larger than 0, it can be equal to 0, and it can be smaller than 0. A and B are, by definition, always positive. They are the magnitude. But so it's determined by the cosine of theta. If the cosine of theta is larger than 0, well, then it's larger than 0. The cosine of theta can be 0. If the angle for theta is pi over 2, in other words, if the two vectors are perpendicular to each other, then the dot product is 0. And if this angle theta is between 90 degrees and 180 degrees, then the cosine is negative. We will see that at work, no pun implied, when we're going to deal with work in physics. You will see that we can do positive work and we can do negative work. And that has to do with this dot product. Work and energy are dot products. I could do an extremely simple example with you. The simplest that I can think of, perhaps it's almost an insult, it's not meant that way. Suppose we have A dot B, and A is the one that you already have on the blackboard there. Right here, that's A. But B is just 2y dot. 2y roof. That's all it is. Well, what is A dot B? A dot B, there's no x component of B. So that becomes 0. This term becomes 0. There is only a y component of B. So it is minus 5 times plus 2. So I get minus 10 because there is no z component. Simple as that. So it's minus 10. I can give you another example. Example 2. Suppose A itself is the unit vector in the y direction, and B is the unit vector in the z direction. Then A dot B is what? I want to hear it loud and clear. 0. Yeah, 0. It is 0. You don't even have to think about anything. You know that these two are at 90 degrees. If you want to waste your time and want to substitute it in here, you will see that it comes out to be 0. It should work, because clearly A of y means that this is 1. That's what it means. And B is z, that means that B of z, this is 1. And all the others do not exist. Well, I wish you luck with that. And we now go to a way more difficult part of multiplication. And that is vector multiplication, which is called the vector product.